Okay, now come to the rotating machine, and maybe we can touch on the DC machine, or maybe not, just at least. So this lecture to introduce you about the rotating machine, the type of rotating machine. We have so many types of rotating machine. What is rotating machine? Rotating machine could be the electric machine, electric power and mechanical power. Right? Mechanical power that is converged to each other, so we can maybe we transform mechanical power into electric power, right? Mechanic to electric. We call this type of machine as the power generation or power generator or generator, right? Electrical generator, we transform the hydropower, the engine power, the steam power to electrical power, or we can call generator, or we transform the electric to mechanical power. So this type of machine we call motor, right? So, and we have so many types of motor. We have DC machine or DC motor, and we have AC motor, AC machine. So first, the machine could be event generator or motor, and the machine could work with DC or AC. It depends on the design. Okay. So the rotating machine is the machine that rotates, right? When it works, you change the mechanic power, so it's the prime mover power, right? In the prime mover power is the torque and speed, right? If you compute the power here, mechanical power will be torque and angular speed, right? T into omega here. And for the electric power, S is will be square root 3 VI, right? Like this, which is P plus JQ here, as we have learned earlier here. Okay. So if you have two parts, which is stator, non-moving part, and the moving part we call rotor. So both parts may have the coil, right? The inductor coil to produce the magnetic circuit, right? To produce the magnetic flux and change from mechanic to electric or electric to mechanic. And we can have both motor or generator. So for motor, we just transform electrical power into mechanical power, right? P electrical into P mechanical to move this shaft, right? And for the generator, we change the power from the engine or from mechanical power from P mechanic to send the electric, right? The current and the voltage to send the electric, or we call this as a generator. Okay. And we have many types of electric machine, right? Or we can have DC machine, right? DC machine, and or we have synchronous machine. The synchronous machine is the machine that need both AC and DC for the operation, right? We need to supply both AC and DC. And induction machine is we need only AC electrical power, right? To drive this type of machine. And then in AC machine, or we can call synchronous as one of AC machine, and usually we use the synchronous machine as the generator, not for motor. And we have induction machine is the most commonly used in motor form, right? Here. For induction machine, mostly we use it for motor, and synchronous machine mostly this is the generator in the power plant. Okay, and then for DC machine we could have also a generator and motor, and for DC machine we can categorize into three important types, which are the series machine, shunt machine, and compound machine. It depends on the circuit, and it depends on the application. For example, series machine will give a very high torque, right? High torque. But for shunt machine will provide you more constant speed. Right? So if you need something that need to punch very hard but don't need a constant speed, right? Just maybe punching machine, for example, you need to or crunching machine, maybe you need a series machine. But for some work that you need to drive something constantly, right? Constantly, you may use the shunt machine, for example, right? Okay, and for DC machine, so we can use it in both for generator and motor as well, right? And we have series machine, shunt machine, and compound machine. Compound machine is the DC machine that mix together of these two types, which are series and shunt machine, right? In this case, okay. You can maybe DC machine is very close to your common life. For example, it's maybe in your toy, right? When you are a children, and it's maybe the car engine starter, right? This is a car starter, and the car battery charger, right? This is a generator, right? When the car engine is turning on, this machine will charge the current to your battery, to the battery of your car, right? And this is to drive the engine to be start, right? To be start, right? Earlier we use the human power, right, to start engine, right? And as you may see in the old movie, right, when they try to start the own type, own model of car, right, we need a human power, right, to drive something, right, to drive some shaft, and then the engine will start. But nowadays we just turn on this motor, right, and this is a DC series motor right here for the car engine starter, for example. Okay, so DC motor are used when the DC power supply are available. So what need for DC machine? So we need DC supply. But when we walked into the factory or in the building or the large building nowadays, we have AC supply as a main power supply, right? So it's maybe we need some special power supply for DC machine, for DC motor, right? But in the car, the electrical system is that is from the battery, right? So we have the DC system. So in the car mostly we have DC supply, right? And some researcher develop the concept of DC home, right? So usually we use the equipment in DC power. For example, in your smartphone also DC, in your television also DC, but there is the converter or the rectifier circuit that transform AC to DC. You will learn this content to how to transform AC and DC. We call this is power electronic circuit. You will learn after midterm with Dr. Salavut, okay, and okay. So in the vehicle electrical system, right, we have the DC from battery, DC source from battery, so it's no problem, right? Or DC may be generated from photovoltaic or solar cell may also generate DC source, right? Solar cell. Okay, and then DC generator are used to generate DC electrical power with mechanical power driven source, right? We can also have DC generator to generate DC electric power. Okay. For example, DC generator used as battery charger in vehicle right here. Just produce the DC power charge to the battery right during the engine start here. So if you turn off the engine for too long time, so your battery will discharge or will leak, right? And will have a self discharge, and you cannot turn on your car, right? From that battery, right? So usually the battery needs this charger. So if you park your car too long time, you need to start it up, right? Maybe after 1 week or 2 weeks, right? And if you charge by this generator, right? This DC generator in your car. And this is the synchronous machine, which is the AC machine. And synchronous machine will usually build in large three-phase power generation. And there are a number of large synchronous motor in industrial, but it's not much less than induction motor, right? This is the usually this type of machine is in the power plant, right? Hydro power plant, steam turbine power plant, and it's rarely used for motor. It's rarely used for motor. Very not much. Okay, and then we also have induction machine. Okay, for induction machine this is the most common driving device here, right? It's the most common driving device in industrial, and it's share approximately 80% of motor use in industrial. So if we walk into the industrial, or if we find the motor somewhere, and we can guess should be induction motor, right? So driving the pump, driving the conveyor, or driving some process in the industrial process. So it usually be the induction motor. Okay, and for induction generator, there are rarely found due to its difficulty in frequency and reactive power control, right? And so maybe we find this type of generator or induction generator maybe in wind turbine, in the wind turbine generation here. They will use in very special induction generator. Okay, and in the even in the EV car, right? EV electric vehicle, electric system that we nowadays we use induction motor, right? Even we have DC from battery, right? From battery, we have battery, and it will connect to some motor drive that to drive the motor, which is induction motor, which is AC, right? This is AC, this is DC. So this circuit uses the power electronic technology to change DC to AC, but we can control, okay, we can control this signal, and so we can control the speed of this motor, okay, in EV car here. Okay, and there are some special motor, for example servo motor. Servo motor are the motor that driven by pump type power supply at feedback control, with feedback control. So it's not driven by DC or AC, but it sends the pump signal and it's control the position very accurate, right? So this type of motor here, we have the controller to drive the motor, and this type of motor is used for example in the motor drive valve. This is the valve, right? This flow control, this is connect to the pipe here, right? And this valve can control the percent of open, right? The percentage of the valve open So how much to open the valve by control by this motor, right? We can control very accurate, right? It's the industrial process here. Or we can use this type of motor for robot arm, right? I think this is for position control. It's very accurate position control of machine, right? So this is servo machine, servo motor. We call servo motor. Usually come with controller, right? We cannot use a motor. This will send the signal to the motor, the power, the spatial signal or punch signal to this motor. Okay. We also have another special machine or traction motor. We call traction motor. The traction motor can be both DC and AC motor, and it's usually driven by power electronic circuit, right? The traction is in the electric train, right? And consume the electric power from maybe from pantograph here, right? From here, the electric will go to this motor, right? And it will control by the power electronic circuit, right? To drive this motor. Okay, this is also one maybe special motor for special purpose. Okay. Okay. Now I will touch on some performance characteristic of electric machine. So how we just buy the motor and use it, but it's better to know that what is the property of which type we should use and how to maintain this motor, how to just maybe basic knowledge to check the motor is okay, is correct or not, right? For example, or something like that. And so as I have talked that the machine is the energy conversion device, so the important property of this type of machine is efficiency, right? Efficiency. What mean by efficiency? Efficiency is the so efficiency is usually the power output, right? Power output divided by power input and multiply. If you multiply with 100 is the percent of efficiency, right? And how much you can use output of this equipment comparing to the 100% of input, right? So if this is generator, if it is a generator for generator the efficiency, what is the output of generator is electrical, right? Electrical output divided by mechanical input, right? By 100%. But for motor, if the equipment is motor, the efficiency, the power output would be, power output is mechanical power, right? And the power input is electric. We supply electric and we get the mechanic, right? There is the efficiency is there, right? And so if the efficiency of the equipment is low, it means that there are a lot of loss, right? The energy loss is there. Yes. Okay. And loss is depend on many factor of the machine, and this is some example of typical value of the loss of generator here. This is the direct current DC generator loss. Yeah. And for the generator, the power supply is mechanical power, right? To drive this machine. Right? To drive this machine. Right? If we have output plus minus DC power, right? And we need to drive, right, by any mechanic, right? P mechanic here. We write this P mechanic as an input, right? This is input, right? From prime mover here. There is so many laws, right? We have laws, rotational laws, state laws, armature laws. The laws in which in heat produced in the resistance, right here, the resistance of the armature or the coil, and or we have the electromagnetic power converse here, and we have maybe we have some brush contact here, right? Because to connect the power to from output, it's maybe this part is moving, so it needs some brush and to touch on the moving part in order to connect for make electricity connection from us to outside the machine, right? Or we have field loss, shunt field loss, right? And then power output with PE is here, right? So with some loss, and we can compute the efficiency, right? The efficiency is be PE divided by P mechanical into 100. If we say in percent, here is percent efficiency, for example. Here this is an example of motor, right? For motor, what happened for motor? We may have this is mechanical power to drive something, right? To drive the conveyor, to drive the pump, right? We supply DC power here, right? PE, we supply DC power to the motor, right? So, and PE will be here, P electrical is here, and we have P mechanical out, so there is the loss is there, and the percent efficiency will be P mechanic divided by P electric by 100% here, right? So this is the loss produced in this machine, right? There is no any equipment with 100% efficiency, right? The loss would be there. Okay. Okay, and another characteristic of the machine that we need to consider is the speed torque curve, right? Each machine will have a speed torque curve. This means during one speed, if you can produce the torque, right? The torque, right? And if we increase, usually if we increase the speed, sometimes the torque is decreased. It's not possible to drive with high torque, high speed, because the power, mechanical power is T into omega, right? Into speed, the torque is into omega. And if you drive, if you want to drive it fast, the torque may be reduced. Or if you drive slower speed, the torque, you can have a high torque, right? Like this, right? And this is operating point here, maybe the operating point of the machine here. Okay. And this is the efficiency, the relation of speed torque, and we can know about is the efficiency of the machine, right? If you use this machine as its design value, you will get a higher efficiency, right? If you use it in this area, right? In this part, this will be okay. So as I talk that we can consider the machine into two modes, right? In the electrical power output mode or mechanical power output here, right? So for figure A is the motor action. We have mechanical power output, right? Here it is electrical power output. If we compute, if this is a three-phase machine, for three-phase machine, this would be S is the 3 VI, right? And power will be square root T VI and cos theta here. And if it's DC, it will be P will be V into I. If this is DC machine. If this is three-phase machine, right? This is the electric power. But for mechanical power, it will be PM is torque into omega, right? Here. Okay. This is PE. So it depends on this is AC machine or DC machine, right? And similarly for generator action, the mechanical power is PM is also T into omega. Electrical power are the same, right? But it's considered as the output of the machine. Okay, I think I will start DC machine next time. Okay, so this time is maybe we have no time for to continue DC machine. So the structure of DC machine and with many types of machine, I think I hope that I can finish next time. Okay, and we have some computation example, I think, and maybe some consider is as a motor, as a shunt, as a compound motor with the characteristic of each machine. Okay, permanent magnets, maybe I will skip this topic, and maybe only DC machine, different type of DC machine is fine. And okay, any question?